Several months ago, I had done a video series on the Oxy LED bars that I had. In retrofitting the three of them, one of them somehow got damaged, and I was unable to repair it despite every possible effort that I could think of. So many different things that I tried, and it just would not come back to life. So what started off as a simple task was just to buy a few more of them because I really liked them. And at the time, I could not find them anywhere. I could find the exact one that I had, but only in cool white, not the warm white, the LED with the phosphors on them that give it that nice warm glow. And I looked pretty much everywhere and could not find them. It so happened that the one that I wanted to keep intact and not tear it apart and do anything to it was the one above our doorway when you enter our house. That particular entryway is nice to have a light on when you walk in. That's motion activated. I went and looked for other brands, and this one, it was quite expensive. It was about $34 for an 84 LED array. It's 84 LEDs, as you'll see in a minute here. The packaging of it, it just feels a lot cheaper than the Oxy LED construction. I used it for about 3 months. It was pretty good. The runtime was good. Because it has 3 rows of LEDs, even though I think the 84 LEDs are just not necessary. The 36 LEDs that I had in the Oxy LED strip that ran longer than this, ran from end to end, it casted just about the same quantity of light. The fumbly bit about this thing is the way that it mounts, and it has a magnetic mount like the others do, but it came with a strip very similar to the one that came with the Oxy LEDs, and I wanted to reuse the strip on the ceiling. I don't want to have to pull it down and put up a new strip just for the sake of changing this. But because it's got this lip on the edge, and the Oxy LED ones have a channel that runs all the way through from end to end, and has a little thin cap. This kind of doesn't really fit exactly in that channel. So I trimmed it a little bit, got it to fit, but it's still not as neat of a mounting as what I had with the Oxy LED one. So I'm wondering if this is a protective coating that is perhaps making it a little bit less magnetic, and anyways caused what happened in the last day or so, which is I went to take this down because the battery was dead, and I grabbed it and it slipped and it slid down the wall and then hit the floor. It's about a 8-foot ceiling. Didn't fall full velocity, still did impact the floor probably from about 3 feet, and it stopped working. I thought, well, I'll give it a charge and see what happens, because it was dead already. The battery was low. So I plugged it in to charge it, and I got something that immediately set off the alarm bells for me, which was that both the amber and the green light came on at the same time. I'm not sure if that's coming. Yeah, you can see it's amber and not green or red, which means that something's going on that's not great. So when I flipped it to on, it came on. This is not its normal brightness. It's really dim compared to what it usually runs at. And then the auto, I don't know if that actually would work. But anyways, it did power on. And then I let it sit to charge for about maybe 2 hours, came back, and it was still in this amber color. So I stopped charging it and thought something must be going on. Maybe I broke it. And so I embarked on taking it apart. As soon as I saw what was going on with it, I stopped, and I thought I'd make a video about it because it demonstrates an important design feature that inexpensively manufactured stuff just doesn't adhere to. So this plastic sleeve comes off. It's got a plastic diffuser, and then you've got your rows of LEDs. I was a little bit curious about how this piece here was assembled, and I pulled on it, and then I could hear something squishing inside, and then I started pulling on it, and I saw wires coming out the bottom here. Flip it around. There are wires coming out the bottom like this, and I kept pulling on it going, well, that must be the battery wires. And it wasn't like I pulled on this hard, this freely moved, so it wasn't like I disconnected the battery at all. And so I pulled it all the way out, and we got the circuit board. But then in here is the battery. There we go. So there's 2 pieces of foam holding this battery in place, and then the battery just kind of slid in into this aluminum channel, which is okay. The other ones were like that too. The battery has the 2 wires coming off of it, and there's no current, anything flowing. Battery didn't get bloaty or anything, even though it was charged. The one thing I did look at immediately was, does it have charge protection? There is charge protection, but what I wanted to really shine the light on here, pun intended, is that the battery terminals are right here. And what they did is, instead of any sort of mechanical securement on the battery, they just tacked it on. That's the sensor. Oh, where did they tack? Oh, there it is. It's over here. So they mounted it right here. There's no mechanical securement of the battery. Even at 3-foot impact, battery with this foam tape must have moved enough inside that it pulled the wires loose, or they were not really well tacked on. The whole thing came loose, and the battery leads were just flapping around. The battery has protection on it, so if the leads touch the inside of the case and they short the protection, it will just kick in and shut the battery off on overcurrent. It just goes back to the design. You have all these through holes. Why is it 2 more plated through hole drills? Strip the wire, put it through the hole, solder it, and then you have not only the solder itself adhering to the plated through hole, but you have a means of securement. Even if this were to be jostled about and the solder would break from the printed circuit board, it would still be attached to the wire. And if you're not going to do it, then really robustly secure things that might move around the cabin, that is the battery, with more than just these little pieces of foam adhesive, because it's going to move. What I'm going to do is probably meter this out and solder it back in place, and we'll just see if it works again. Definitely 22 gauge. Okay, so I think this is positive, this is negative. Turn on the soldering iron. Stop shorting the battery out. I'm going to solder it back into place just the way it was, and I'm going to tape it down inside the enclosure so that if it does fall again, it will have a little bit more securement. Fold that over on itself just to give it more to bite onto. And I will get this one in place. And yeah, I could have tinned the wires. That's usually what I do. There's big blobs of solder there, so by the time it slides down into the solder and there's a little bit of flux left over, you can see the smoke coming up, which is the flux, that it just grabbed it. So it's back together. Let's see if I blew it up. So I will put the clamp meter on here just to watch the current going into the battery. Zero that out, put it on the battery. Okay, and then we'll plug it in. The red light is on. That's the red light, as opposed to the amber light, which is no mode. That is, it's both charging and done charging at the same time. That seems kind of low. It may be nudging it. Actually, it may be doing its little dance where it's testing to see if the battery voltage comes back up. Let's check it. And DC voltage, DC. Yeah, see, it's at 2.8 volts. It is climbing. So 2.8 is kind of low, which is it climbed above 2.9 volts, and now it's jumped to 825 milliamps. 78 milliamps, 80 milliamps is like about 1/10. Just nudging it to see if the voltage comes up, and then once it got above 2.9 volts approximately, I couldn't exactly tell because I dropped the probe tips, popped off, kicked into high charge gear, which is about 825 milliamps. It's a 2000 milliamp hour cell, 7.4 watt hour. So it'll charge it up in about 3 hours, maybe 4 hours. Whoa, why is it so hot? That is really hot. It's designed to be that hot? What the hell was that? There's a chip underneath there. Okay, let me turn the light on. Light works. So the battery's in the right orientation. Okay. 3.1 volts, it's falling. So let's check that out again. I'm gonna get the USB tester. Maybe there's another short somewhere that I wasn't aware of. I would imagine to draw maybe 3 or 4 watts. Yeah, it's consistent, about 5 watts. There's 845 milliamps. So 827 milliamps at about 4 volts. Okay, there's some loss in there. Seems to be working okay. 4.3 watts doesn't seem out of the ordinary. Perhaps when I had this turned on? No, it still limits itself. But that is really freaking hot. What is it measuring? 77 is the highest it got up to. 77.2 Celsius. It's pretty hot. I don't know what component is underneath there. Oh, there's a little charge controller thingy. It has a bunch of stitching around it. Stitching is just for, you can sort of see it. That is so damn hot. Battery temperature is fine. Nah, the cell is fine. 23. So it's not a matter of too much current going into the cell. That's not a problem. It's not too much current flowing into the controller. Maybe just another indication of poor design, because that chip is getting really, really hot. ADC is kind of, that's the backside of the board. I don't know, maybe this thing's always just gotten hot when it's charged and I just haven't noticed it. It's like they knew it was going to get hot in that area a little bit, because you can see how they have the ground. I'm pretty sure this is the ground. Here is the negative, and they made it a pretty large copper area. It's got quite a bit of stitching around it, especially here and here. And the area here where there's a lot of stitching, it corresponds to where the charging chip is on the other side. I guess I recall this thing getting warm when I charged it. Let's see if I can get the infrared thermometer inside there on an angle to see what the chip temperature is. Maybe it's that little current limiting resistor. Oh, I wonder if it's that resistor. Yeah, 'cause I don't think this chip is super hot. Let's see if I can get my finger in there. The micro USB housing, ow, is hot. And that chip, I can't get my finger in there. Well, I'm gonna put it all back together and let it charge and see how it goes. I'll just put this back in here. It's kind of a fiddly part of this. So maybe I shouldn't be charging it while I'm doing this. You know? Yeah. Slide that down over there. Should be enough length. Yep, there's enough length. Put this little sticky pad back where it was. Oops. Ram it up against the, it's just not really a great way to hold that battery in. I might actually put another piece of tape over this because it's just not enough. I'm just gonna go with just some regular electrical tape. No, actually what I'm gonna go with is the all-weather and all the different tapes that I have. I'm going with the all-weather super sticky Gorilla Tape. I'm not gonna use a lot of this because I don't want to make it impossible to remove the cell again. But I'm gonna put a piece of tape right there. And this stuff is super sticky. So it's nice because the circuit board will kind of hold the battery now in place. There'll be a little bit of friction. It's a little bit janky, but it's better than it was. I think that's it. So now I'm gonna put the circuit board. Oh. I didn't think this all the way through. How did they do this? The wires are only so long. Well, that's goofy. Maybe they... This is just silly. I don't really know what to do here. The tape's not going to work. Because unless what they did is they pushed the... Ooh. That wasn't great. They pushed the cell forward. This is not long enough. So I need to get this all the way into the channel. Now it's sliding into that channel. And then there's another channel in here that the plastic rides on. This is the best I can do. Forgetting about the battery, I'll protect these connections and I'll I was going to use electrical tape, but electrical tape isn't sticky enough. There we go. So what I'm going to do is 2 different spots away from the edges. Let me get the battery slid in first. The battery was flipped this way. Oh, the one thing I wanted to check before I put all this back together, this piece, this inserted piece that is for, is it actually got a coating on it, like a protective coating? Oh, I think it does. How are you supposed to get that off? I never really got a good connection to the ceiling. And I was like, what's this blue stuff on the back? There's no way to get the blue stuff off unless you scratch at it. And it didn't look like it really was intended to come off. Anyways, if you have a problem with this type of light not sticking to the ceiling, it's because of this piece of metal that has a protective coating on it. And peeling that off should make it adhere to the ceiling with the magnetic strip a little better. The battery being pushed in here like this, and then you have all these through-hole components that can interfere with it if it were to come loose, especially when it's only being blocked from interfering with those components with a piece of foam tape. What I'm going to do is put some of that over those components, and then I'm going to push the battery in. I'm going to push this little piece of foam in there because the components will push it back further as it goes in. Or I could try to do that with the plastic, this plastic piece. I don't know if that's going to work or not. Yeah, it's working. Okay, push it back till it's hit where it's back in here where the other piece is at, and now it's up against it. And the final thing that I'm going to do is take these 2 pieces of wire and kind of put them over here. Really like to keep them away from other through-hole components, but that could be a little bit challenging. And there's not a lot of circuit board here to work with, so I'm just gonna try to wrap it like this, so that if it does get pulled or shocked, there's a little bit of strain relief here, as opposed to pulling right on the wires. It's better than nothing. If you're not going to do a plated through-hole connection where you mechanically secure the wire with solder on the opposite side of the board, then at least put something on the wires to act as a mechanical securement. And it also can be, especially at low voltages, a decent insulator. Anyways, sliding it all back in there just to make sure we're not pushing too hard on anything. And look down the inside here to make sure we're not pressing on the battery. I don't believe we are. We are pressing, what I'm hitting is the foam. Yep, it is the foam. So I'm going to push that back. I'm going to keep pressing on it to push the foam down. I think you can see, I don't know how well this is going to come up, but with a little extra light. There you go, you can see the wires down there. There it is. Anyways, push that all the way back in there. That foam is just, oh, where did this foam come from? Oh, it was on top of this screw. I think that's good enough. And I'll put a little bit of tape, a tiny little bit of tape over the connections so that if they were to come loose, they wouldn't just immediately touch each other. There's protection on the battery, so this isn't really necessary, but I'll feel better knowing it's there. And that could just go like that. Suboptimal solution here, but I feel better. That's all that matters. So slide it in there. Let's put this diffuser back in. I think it goes the other way around, actually. Yep, it goes the other way around. That's not fitting in there. That's supposed to line up. Is the circuit board not lined up? The guides are. So strange. Maybe the circuit board? But the circuit board is attached to this thing. Oh, there it goes. Okay, so now it's back on there. It's snapped a little bit. I didn't notice it snapping before, but. Okay, and on the other side. Okay, on. Auto is working, cool, off. I'm going to put it back on the charger, and we'll see if we get any short circuits or any sort of unhappiness. Red light's on, 4.342 watts. I never measured the wattage before when I was charging this thing, so there's nothing really to compare it to. That's it for this video. Hopefully you enjoyed it. If you did, give it a thumbs up, and I'll see you in the next one. Take care.